Welcome to the very beautiful, important and basic chapter of SSC level chemistry and students of English version basically and Cadet college students. This chapter is something that will make the foundation of the knowledge of chemistry. You know that the main content of this chapter, which is chemical bond, that has been discussed here. Every single topic will create your foundations, and if you understand all these materials and all these things clearly, then I hope that you will be able to complete the next chapters without any problems. And then if you understand these things, you will feel the beauty of chemistry, I promise. So I'm thinking to upload these chapters, including some different series of videos like before. And as this is a chemical bond chapter, we need to understand what is chemical bond and why atoms combine together and forms molecule. And if you see the content of this chapter, you'll feel good. Like first one, you need to understand the valence electrons, you need to understand valency, radicals, chemical formula. Of course, this is something very good. I mean, you see there is a link between in this topic. If you understand valence electron, if you understand valency and then radicals, then you can form and you can understand that how chemical formula is being formed. And then octet and duet rules, ionic and electrovalent bond. I mean, we will definitely discuss three major type of bonds in this chapter. That is ionic or electrovalent bond, which is formed by giving and taking of electrons, and then covalent bond is about the sharing electrons. This is very beautiful. And then we need to understand what are the characteristics of in this between ionic and covalent bond, what are the differences in between them, and so on. And lastly, we need to understand what is metallic bond. So usually we will focus in this chapter on three major types of bonds, which is ionic or electrovalent bond, covalent bond and metallic bond. Now you see that in this video I shall try to cover up first two topics, which is valence electrons and valency. And then in the second video I shall discuss about radicals. You know most probably that you heard about the ammonium, phosphate, nitrate, sulfate and carbonate. This is about radicals. I will explain more about it in different videos. And then of course chemical formula. This is the basic of this chapter. So if you understand how this chemical formula is being formed, then you can see what are the valencies in between these atoms and how it forms through ionic or covalent bond. And if you see any compounds, you can identify either it is ionic bonds or even covalent bonds. So it's all about your basic, that how much you know, and then you can identify either this is chemical bonds and this ionic bonds or even covalent bond. So first, if I go first the definition of chemical bond, you'll see that the force of attractions that binds. So that is very important things. Binds. So atoms are binding together to form a molecule. So we will be discussing about the forming molecules with the different atoms and how it's forming. So defining the chemical bonds is that the force of attractions that binds two atoms in a molecule is called the chemical bonds. It's a very simple definition in one line. So I think you can remember the definition of chemical bond, that attraction. So the force of attraction that binds atoms to form a molecule, it's called a chemical bond. Well, if you understand that, then you need to know that what is valence electrons. So if I want to give you some idea, suppose if I say that you know about carbon, in your previous study of periodic table, you know that carbon, the atomic number of carbon is 6. So and of course you know the electron configurations. This is the nucleus and this is the first shell, I mean the K shell. And then in the L shell there are 4 electrons. So now you see that in the first shell, that means in K shell, in 1s orbital, there are 2 electrons. And in the second shell, there are 4 electrons. There will be in 2s orbital and in 2p orbital. So in this case, if we say that 1s2, 2s2 and 2p2, this is the electron configuration of carbon. Now you think, how many electrons are in the outermost shell? 4. So you know that the electron configuration of carbon 6 is 2, 4. It means that in 1s orbital, that means in K shell, it has 2 electrons, and the second shell, that we said L shell, it has 4 electrons. So the valence electrons of carbon is 4. And even if you see in case of neon, so we know that neon is 10. So it means 2 and 8. As it is inert gas, so you know that as it has the most stable electron configurations, it will have 8 electrons in the outermost shell. So as it has 8 electrons in the outermost shell, that is why the valence electrons of neon is 8. So what is the definition of valence electron? We can say one thing, that the number of total electrons, that is very, very important. If you want to know that what is valence electrons, valence electron, then the definition is the total number of electron in the outermost shell of any atom. So the outermost shell or energy level of an element is the valence electron of that element. So we are defining the valence electron. So we can understand, we can easily find out that the number of electrons, the total electrons of the outermost shell of any element, like zinc. You see about zinc. So we know that atomic number of zinc is 30. So if we go 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. Now you see that there are 30 electrons is organized in the atoms of zinc. So in the first shell it has 2 electrons. In the second shell it has 8 electrons. In the third shell it has 18 electrons. And in the fourth shell it has 2 electrons. So altogether it has 30 electrons that is organized in the 4 shells. So K, L, M, N shells. So we can say that the N shell of iron has got 2 electrons. So the total valence electrons of iron is 2. So we can easily identify the number of electrons that is present in the outermost shell of any atom of an element. That is the valence electron of that element. So even if you find any element, you can go for like the bigger amount like silver, uranium, tellurium, even francium, you can got it. So usually what we see that it like magnesium is the smaller one, the 12, it is 1s2, 2s2, 2p6, 3s2. So you got it that in the first shell it has still 2 electrons, in the second shell it has 8 electrons, and in the third shell it has 2 electrons. So the outermost shell of magnesium contains 2 electrons. So it means the valence electron of magnesium is 2. Now you think about the valency. This is the most important part. The valency is the ability or the capacity of any atom combined with another atom of an element to form the molecule. So valency has some different concept. So if we see that valency has some different concept, that we can say that the capacity of an atom, to bind with another atom to bind with another atom of molecule, another atom of an element, of any element, to form a molecule. To form molecule is the valency of that element. So what is the different concept about the valence electrons and the valency? These two are not same. So the number of total electron of the outermost shell of any element is the valence electron of that element. But in case of valency, we need to think that the capacity of binding with another atom of an element to form molecule is the valency of that element. How? Suppose, if I think one thing, like sodium, or even you can go for like hydrogen, that hydrogen is binding with another hydrogen to form hydrogen molecule. So we can see that in hydrogen molecule there are two hydrogen that is attached with each other with sharing one electron. So as it is sharing one electron, it has only one electron in this first shell. So as both hydrogen is shared one electron, here the valency of hydrogen is 1. But you see in carbon when it forms carbon monoxide and when it forms carbon dioxide, you'll have an idea that definitely that mono and di. In case of carbon dioxide, carbon and oxygen is sharing 2 electrons each other. But in this case, one carbon is attached with 2 another oxygens where it's forming same covalent bond. So as here it's sharing the capacity of carbon and oxygen shared in this molecule, actually in carbon monoxide, then the valency of carbon is 2 here. But here the valency of carbon is 4. Why? Because the valency varies, and that is why when some elements have more than one valency, this is called the variable valency. And like iron, we know that iron valency can be 2 and 3. So now you may have a questions that why there is a variable valency, from where this concept comes. Like, well, I need to explain it more about when I will explain that the electron configuration on the excited state, when an orbitals, electrons from one orbital to another orbital, they can jump over, and then the number of odd electrons increase, and so that the variable valency appears. Iron has 2 different valencies, like 2 and 3. And when, you must know another words, that when this less amount of valency will be used in any molecules, then the pronunciation should be as. But when the maximum valency will be used in any molecules, then the pronunciation should be ik. So we can say that when 2 valency will be used in case of iron, that it can be like with chlorine, that we can say ferrous chloride. Or even in case of 3 valencies when we used, then we can say that this is ferric chloride. So I hope you understand. And of course, you see, like oxygen, we know that oxygen valency is 2. How? Because we see that when oxygen form a water molecule with hydrogen, so 2 electrons is shared. 2 electrons is shared with hydrogen, and hence the valency of oxygen in water molecule is 2. So it's shared with 2 electrons, so the valence is 2. But the thing is, the valence electron of oxygen was not 2, because we know that from the chemical formula the atomic number of oxygen is 8. So it has 6 electrons in the second shell of oxygen. So the valence electron of oxygen is 6. But here we see the valency of oxygen is 2, as because the capacity of shared bonding with hydrogen in this molecule is 2. So oxygen valency is 2 and hydrogen valency is 1. So when we know the valency, then we can understand that how chemical formula is formed. And I shall upload this chemical formula in other videos with the explanation of all valencies of elements, so that you can understand how chemical formula will be formed. But here I'm just giving you that idea of valency, that how this valence will be countable. And of course you know that usually valency are 2 types, like electrovalency and covalency. But in bigger aspect we can say that valency can be 4 types. Like I'm coming with this idea. So you must know the definition of electron, valence electron and the valency. Okay, so you go with that. Suppose valency, usually it has 2 types, like electrovalency. Electrovalency, though is the same word, and one word, but I'm reading in different form, like covalency. Now you need to know another thing, that valency can be divided into 4 types also. That is, we can say that number 1, okay, number one is maximum valency. This is very important. I'm coming with the idea that maximum valencies, and then you can say that active valency, and you can have an idea that latent valency, and then the last one is variable valency. So we got idea that valency can be 4 types, and now this is very interesting part, that to identify that what are the active valencies of any atoms and in a different molecules, what are the latent valency of an atom in a different molecules, like I'm giving us some idea, and what are the variable valencies. I promise that I'll upload a video about the variable valencies, why the valency can varies. Now look at this. What is the maximum valency? I think the word itself expressing the definitions, that what is the maximum valencies, what is active and latent. Okay, from the name you can have some idea that why the naming is like that. Think about something. Like say, previously I said that carbon has 2 valencies, and even iron has 2 valencies. As this element, this carbon element has 2 valencies, so it has more than one valencies, it's called the variable valency. So those element has more than one valency, they are called the variable valencies. And now we need to think about the active and latent valency. So among these 2 valencies, which is the maximum? 4. So the maximum valency is the maximum valency of and between these 2 variable valencies. So here 2 and 3. So this is the maximum valency. Okay? So when we write carbon monoxide, we know that in this molecule the valency of carbon is 2 and valency of oxygen is 2. And here when we write carbon dioxide, then we can see that in this molecule the valency of carbon is 4 and the valency of oxygen is 2. When you see the structure, then you can find that yes, carbon is attached with another 2 oxygens like this. So carbon is using 4 valency here while it's forming carbon monoxide. So you see that while forming carbon monoxide, 4 valency is used, but in case of carbon monoxide, valency 2 is used. So here we know that among this variable valency, 4 was the maximum, but here 2 was used in carbon monoxide. So in carbon monoxide, we can say that maximum valency is 4. In carbon monoxide, active valency was 2. So the latent valency is 2. Why? Because the latent valency is the difference between the maximum valency and active valency. Okay, but if you see in carbon dioxide, the maximum valency of carbon is 4. We know it. But in carbon dioxide, the active valency is 4 also. So the differences between the maximum valency and the active valency is 0. So in carbon dioxide, the latent valency is 0. Okay? Do you really understand that what I am explaining here? Because you need to know that 4 types of valency depending on the variable valency. So if any elements has more than 1 valencies, they are called the variable valencies, and among these variable valencies, the maximum one should be counted to find out the latent valency of any molecule. Okay? So if you see again one thing, like, okay, suppose you know that sulfur, it has 2, 4, 6, 8, 4 variable valency. Sulfur, even in chlorine, it has 1 and 7. Suppose in phosphorus, it can have 3 and 5. 3 and 5. Now you may have a question that why 3 and 5? I said that I will definitely upload a videos when electron configuration is changed in case of excited state. And then when it was excited, then 1 electrons or more than 1 electrons can change their orbitals so that the number of odd electrons is changed, so that the valence is always changed. So in case of phosphorus, you'll see that when you write phosphorus trichloride, or even when you write phosphorus pentachloride, now you see that you say this is trichloride, so the valency of phosphorus is using here is 3. So the active valency of phosphorus in phosphorus trichloride compound is 3. As we know that among these 2 variable valencies, this is the maximum. So here in phosphorus trichloride, the maximum valency is 5. But active valency in phosphorus trichloride is 3. So the latent valency of phosphorus is 2. Because I deduct 5 minus 3. I deduct 3 from 5, so it is 2. But in case of PCl5, which is phosphorus pentachloride, here the maximum valency of phosphorus is also 5. But you see the active valency is 5 here, because as you know that phosphorus pentachloride, the valency of phosphorus was 5. Now if you see that if you deduct both sides, you will have 0. So the latent valency of phosphorus in phosphorus pentachloride is 0. So I hope you understand that how to find out these 4 valencies in a molecule. Before that, you need to know that what are the variable valencies of any elements. And for that reason, and to understand that, we need to know that what are the valencies list of these elements. At least we need to know 40 elements, first 40 elements. SSC students of English versions and Cadet college students even asked that how many elements we need to memorize. I said if you are talented people, so you can memorize the whole periodic table. Why not? I know personally a lot of students who have the memorizing power well, and they know the whole periodic table. No problem. But if you have limitations, but if you want to know less, then I say that okay, fine, first 40 you can go for. So I hope that I make you understand in case of valence electrons and what about the valencies. So in this class I'm just finishing line up this one, and then next class I shall be coming up with the radicals and also the chemical formula. So see you on the next class. Stay well, stay blessed. Bye.